Alright, let's dive into something mind-blowing. Imagine staring at the sun, not just a blurry orange disk, but its surface in such detail you can see tiny whirlpools of plasma. Sounds like sci-fi, right? Well, it's real. Astronomers just released the highest resolution image ever of the sun's surface, and it's changing how we think about our star. Here's the thing, this isn't just a pretty picture. It's a game-changer for solar physics. What makes this really interesting is the level of detail. We're talking about structures so small they're like trying to spot a coin from 180 kilometers away. Personally, I think this is where science gets poetic. The sun, this massive ball of fire, has these delicate, vortex-like patterns swirling on its surface. It's like discovering a hidden language written in plasma. And these aren't just random swirls, they're linked to something called Kelvin-Helmholtz instabilities. Sounds fancy, but it's basically what happens when fluids move past each other at different speeds, creating ripples and vortices. Here's where it gets wild. These instabilities might explain one of the sun's biggest mysteries, why its outer atmosphere is so ridiculously hot. I mean, the surface is already 5,500 degrees Celsius, but the outer atmosphere? Millions of degrees. That's like finding out your backyard pool is suddenly boiling while the faucet is just running cold water. What this really suggests is that these tiny processes, happening at the edge of what we can even see, are driving massive phenomena. It's humbling, honestly. We've been studying the sun for centuries, and it's still full of surprises. One thing that immediately stands out is how these vortices are tied to magnetic fields. The sun's surface is a magnetically active area, especially near sunspots. These whirlpools aren't just pretty, they're moving magnetic energy around. From my perspective, this is a huge deal. Magnetic fields are like the sun's nervous system, controlling everything from solar flares to space weather. If these vortices are influencing that, we're looking at a whole new way to predict solar activity. Imagine being able to forecast space weather like we do hurricanes. That's the kind of leap this could lead to. But here's a detail I find fascinating. These vortices are happening at the edges of granules, these cell-like structures that cover the sun's surface. Granules are basically convection cells, hot plasma rising and cooler plasma sinking. What many people don't realize is that these granules are massive, up to 2,000 kilometers wide. And yet, the vortices are just tiny fringes, barely 20 kilometers across. It's like discovering a hidden microcosm within something already gigantic. If you take a step back and think about it, this is nature's way of showing us that complexity exists at every scale. This raises a deeper question: how much more is the sun hiding? We've only just scratched the surface, literally. The Daniel K. Inouye Solar Telescope, which captured this image, is like giving astronomers a new pair of glasses. And what they're seeing is rewriting the textbooks. Personally, I think this is just the beginning. With better tools, we're going to uncover even more about how the sun works, and by extension, how stars across the universe operate. In my opinion, this discovery is a reminder of how much we still don't know. We live in a time where technology is letting us see the universe in ways our ancestors couldn't even dream of. And yet, every answer leads to more questions. Why do these vortices form? How exactly do they heat the atmosphere? What does this mean for other stars? It's a rabbit hole, and I'm here for it. So, here's my closing thought: the sun, our closest star, is still full of mysteries. And that's exciting. It means there's always something new to discover, something that can shift our understanding of the cosmos. What do you think? Does this make you see the sun in a new light? Let me know in the comments. And hey, next time you look up at the sky, remember, those tiny whirlpools are up there, shaping the star that gives us life. Crazy, right?